Hello students, welcome back. The topic that we are going to learn today is that how to find out class boundaries and a few other things, that is cumulative frequency, relative frequency and midpoints when the data is finally organized. Alright, so let's get started. Okay, so first of all we are talking about the classes which are discrete. Now discrete classes or discrete data means that we are talking about that organization in which the observations were given in whole number form. Alright, so that was the discrete data. Whenever the classes are when the data is in discrete form, so what we are going to do is, that is in the whole number form, in order to find out class boundaries, we will be subtracting 0.5 from lower interval and add 0.5 in the upper interval, like this. See, these were my classes from the previous example that we organized. Alright, so in this, the first class lower limit is 87. So if I subtract 0.5 from this value, the answer is 86.5. Alright, and if I add 0.5 in the upper interval, that is 94, the value I get is 94.5. Alright, so this is how you calculate a class boundary. Alright, so we need to calculate class boundaries for all the intervals. Now for 95 and 102 we're gonna do the same thing. We're gonna subtract 0.5 from the lower interval and we will be adding 0.5 in the upper interval. And this is what the final chart is, that in this chart we have classes, we have intervals, frequency, and then the class boundaries. Alright, so as you can see, because of these boundaries, the value, this ending and starting position of two classes are now same. Alright, so this is what the boundaries do. They make the data, they make intervals continuous. But in general, when we need to organize the data, we always make it a discrete, a gapped data, rather than making it a continuous form of data when we have done in boundaries. So boundaries, what boundaries used to do is, they're gonna end a class at one point and the second class is started, the second class boundary is started from the same point. So that is how we calculate a class boundary. Moving on. Alright, so for continuous data, now we have already read, or we have already learned that what is continuous data and how we organize a continuous data. Alright, so in order to find out class boundaries for continuous data, what we are going to do is that we're going to subtract 0.5 from the lower interval and we will be adding 0.5 to the upper interval. So this is the case. This was the previous example I have used. We have already organized this data. So now in this example, as you can see, I have subtracted 0.05 from the lower interval of the first class. So the result is 1.55 and I have added 0.05 in the upper class in the upper interval, so the result I got is 2.05. Repeating all these processes gives me values 1.55 to 2.05. Then the starting value for class boundary of second class is 2.05 to 2.55, and this is the complete chart. You can, what is the rule? The rule is that you need to subtract 0.05 from the lower interval and you have to add 0.05 to the upper interval for continuous data in order to make its class boundaries. Moving on, we are now moving on to the cumulative frequency. First of all, we will be talking about the cumulative frequencies, that basically the frequency, in frequency distribution, the values or frequencies occurs between the upper and lower limits. Alright, but if the number of values occur under the upper boundary of a class, then frequency is known as less than frequency, cumulative frequency. Similarly, if the number of values occur above or over the lower boundary of a class, that frequency is known as more than cumulative frequencies. Alright, so first of all, we will be learning about how to calculate cumulative frequencies. Okay, so in order to find cumulative frequency less than, we will start with first frequency of first class, then add frequency of second class to the preceding answer. Now how it is done? All right, okay, so this was an example. This was the data that I have used earlier. So in this, the interval starts from 87 to 94, 95 to 102, 103 to 110. The frequencies given are 2, 3, 4. In order to find out cumulative frequency less than, what we are going to do is we're going to start with this value first. Alright, that is 2 plus 0. Initially it will be 2, or you can write it down as 2. Alright, then if we wanted to find out cumulative frequency for next class, what we are going to do is we're going to take this answer, that is 2. Alright, okay, now out here I have marked answers with red. Alright, so you can know that how these values are coming, from where these values are coming from. Alright, so 2, the answer that I got is 2. Now I need to find out, since I need to find out the value CF for CF less than for second class, the frequency of second class is 3. So 2 plus 3 is 5. Now for third class, in order to find out CF for third class, I am using this answer, preceding answer, that is 5, and adding frequency of the third class to get the final answer, to get the CF less than for third class. Okay, so if you just wanted to go through it again, it's like we have started with the first frequency as it is, and then with that answer we start adding the preceding frequencies to get the following cumulative frequency less than. This is the final answer. See, for CF less than, we have started with 0.2, then 2 plus 3 is equals to 5. Now this 3 is frequency 3. Alright, then 5 answer carry forward, plus we wanted to find out frequency for CF for third class, so the frequency for third class is 4, so 5 plus 4 equals to 9. Then 9 as it is, answer copied down. 9 plus 6, this 6 equals to 15. 15 as it is. 15 plus 19 equals to 34. 34 as it is, plus 8. 34 plus 8 equals to 42. Then 42 plus 5 equals to 47. 47 plus 3 equals to 50. Now as you can see, we started with the minimum frequency, or we can say that we have started with the first frequency of the first class, that is 2, and we ended up at the maximum frequency, which was 50, because the number of observations were 50, so we ended up at 50. And this is the basic rule, that you'll start with the first class frequency, and by the end of the CF, the last class CF will be the summation of f, the sum of frequency, the total sum of frequency. So that will tell you that you have done it in correct order or not. If this number is not equals to the sum of f, then it means that we have done some calculation error, and we have to go through it again and check that where that error has been made. Alright, so this frequency should always be, the last class CF should always be equals to the summation of f. Alright, so moving on towards cumulative frequency more than. In order to find cumulative frequency more than, we will start with maximum frequency as CF of first class. Then for next class, we will subtract the answer obtained in CF by frequency of preceding class. Now what does that mean? Alright, see, earlier in less than, we saw that this 50 was actually the answer for the last class. Alright, but for more than, we're going to start with the maximum point, that is summation f point 50, or whatever the CF the summation of f is. Alright, in this case it was 50, so 50 carry forward minus, now in earlier we were adding, now we are subtracting. Now which value to be subtracted? 50 minus the preceding frequency. Alright, so 50 minus 2, 48. 48 carried forward minus preceding frequency 3, 45. Then you can see out here 45 minus preceding frequency 4, 41. 41 minus 6, 35. 35 minus 19, 16. 16 minus 8, 8. Alright, 8 carry forward, 8 minus 5 equals to 3. If you just go back, 3. Alright, so this is the way of calculating. As you can see, we have started with the maximum point or the maximum frequency, that was 50 summation f, and we ended up at the last class frequency, which is 3. In less than, what we did was that we started with the first class frequency and we end up at summation f. In more than, we will be starting with maximum, that is summation f, and we'll end up at last class frequency, which is 3. And this is how to identify the answer. There's another way of doing this, of calculating more than frequency, which is this. Alright, in this way we will start at the bottom, we'll start from the bottom, and we'll end up and we'll go upwards, right? So this 3, like we used to do it in CF less than rule, we keep on adding the frequency of the preceding class. Now we will be adding the frequency of the proceeding class in order to find out CF more than. Now how it is done? See, 3 copied, or 3 plus 0 equals to 3. Alright, then for this class 3 carried forward plus 5, 8. 8 carried forward plus 8, 16. Now 8 out here, this 8 black is representing the frequency, this 8 in red representing the answer that we got earlier. Alright, so 16, see, 16 plus 19, 35. 35 plus 6, 41. 41 plus 4, 45. 45 plus 3, 48. 48 plus 2 equals to 50. Okay, so this is how you can calculate CF. You can use this additive method or you can use this subtractive method. That is completely up to you, that you start with the max, with the summation f, and then you just move forward gradually, or you can do it that you just start with the bottom, that is last class frequency, and you move towards the highest, that is 50. So this is completely up to you. You use subtractive method or you use additive methods, both will give you the same answer. Moving on, we're now going to learn about the midpoints. In order to calculate midpoints of any class, we will add the lower and upper limit of that class and then divide it by 2. Alright, so in order to find out, this was my class interval. To find out its midpoint, what I'm going to do is that I'm going to add these values 87 and 94. Alright, and then I will be dividing it by 2 in order to get midpoint for my first class. Then for this class, 95 plus 102 divided by 2 equals to 98.5. Then 103 plus 110 divided by 2 equals to 106.5. And this is how the complete table looks, that for each classes the midpoint is calculated out here. You just need to add these two limits, alright, the numbers that are given in these two limits, the two limits number, then you will be dividing it by 2 in order to get midpoints of the following class. Alright, the next topic is relative frequency. In order to find out relative frequency, we have the formula. Now to find out relative frequency, the formula is RF equals to F divided by summation of F. Now it is done for each and every class. Alright, that is to determine the relative frequency of each class, we will divide the class frequency to the number of frequency. Now we know that let's say if in this table the class interval from 87 to 94 frequency was 2, and if I need to find out relative frequency of this particular class, what I'm going to do is I'm going to divide this frequency with the total number of frequency that has been calculated, and the answer I got is my relative frequency. See, in this particular example I'm using I'm using out here, the summation f was equals to 50. Alright, so if I need to find out frequency for this particular class, so what will I do is that I'll divide 2 by 50 equals to 0.4. For this, 3 divided by summation f, that is frequency for all the classes, and divided by the total frequency, and this process is particularly repeated for all the classes. There you go. 2 divided by 50 gives you 0.04. 3 divided by 50 gives you 0.06. 4 divided by 50 gives you 0.08. 6 divided by 50 gives you 0.12. 19 divided by 50 gives me 0.38. 8 divided by 50 gives me 0.16. 5 divided by 50 gives 0.1, and 3 divided by 50 gives me 0.06. Now the interesting thing out here is that the sum of all the values of the relative frequency must be equals to 1. Alright, it always and it should be equals to 1. Alright, so if you just add all these values, 1 will be your final answer. Okay, if I just add all these values, my answer will be 1. Alright, so the thing is that for relative frequency, what we do is for every frequency we divide it by the total frequency. Let's say if we have 2, so we will be dividing it by 50 to get relative frequency of first class. For second class, the second class frequency divided by the total frequency, and that is how you calculate it, and the sum should always be equals to 1. Now the topic that we are going to learn is percentage frequency. Alright, for percentage frequency, the formula is CPF is actually represented as percentage frequency. RF means the relative frequency. So we have calculated relative frequency earlier. Alright, so what we are going to do for percentage frequency, we're going to multiply relative frequency by 100 to get the percentage frequency. And this is how it's done. So the initial values 87 to 94, for intervals 87 to 94, the frequency was given as 2. In order to find out its relative frequency, we know that we need to divide this value by the total frequency. Divide frequency by the total frequency. This is what my answer is. In order to get percentage frequency, what you're going to do is you're going to multiply relative frequency with 100, so that you'll get all the percentages values like this. Alright, and since the sum of relative frequency is 1, then the percentage value should always be equals to 100%. So if you just add all these percentages, you'll get this answer that is equals to 100. Alright, so this is what my final table will look like for this particular example. So for that example, what I have done out here, this is my class interval column, which initially the data was given to me, and I've organized it into these classes. The frequency, the correspondent frequency, this is the column for frequency. Then for each class boundary, the column is let's say if you wanted to go through and repeat everything, so it's like for class boundary, what you're going to do is we're going to add, we're going to subtract, and we're gonna add 0.5 from the lower and upper limit of the intervals. This is my CF less than column, and this is my CF more than column. For midpoints, what we are going to do is, for midpoints, we're going to add these two interval values and divided it by 2, so that we'll get the midpoints of all the classes. For relative frequency, what we are going to do is we're going to divide this every frequency by the total number of frequency to get frequencies, to get relative frequencies, right? For let's say if I need to find a frequency for this particular class, so the frequency out here is 19, all right, and if I divide it by 50, it will gives me 0.38. all right, and if I need to find out its percentage value, I'm going to multiply this relative frequency with 100, so that I'll be getting my percentage value. And we need to know that the sum of all the relative frequencies should always be equals to 1, and if it is 1 and if we multiply it by 100, the result out here relative for percentage frequency is also 100%. all right, I hope that you have understood these quantities, that how we calculate these quantities. For continuous data, the only difference will be these boundaries values, how the way actually you calculate these boundaries values. Rest, the process for calculating CF, less than, more than, midpoints, RF and percentage frequencies are all same. all right, only the difference is in the formula for class boundary, that is for continuous data. What we are going to do is we're gonna subtract and add. all right, we're gonna subtract and add 0.05 from lower and upper interval. So you're gonna subtract 0.05 from lower interval and we're gonna add 0.05 in the upper interval to get the class boundaries, but that is only for continuous data. Rest, the process for CF, less than and more than, midpoints, RF and percentage IF is same. I hope that you have understood how to calculate these parameters. Thank you.